Hi, everyone. Thanks for joining our webinar. I'm Chris Lopez, one of NetBrain's technical marketing engineers. And today I'm joined by Raj, one of our sales engineers who will be leading the demo portion. Today, we're talking about how to supercharge your incident response with NetBrain and ServiceNow. We'll show you how many day-to-day operations you can simplify by integrating these two systems together, and show you a live example of how this kind of deployment is more than the sum of its parts. Our agenda today is pretty straightforward. First, we're going to go over why incident response needs to improve in the first place, discussing briefly manual processes and inefficiencies that hinder organizations and turn NetOps into a choke point for business productivity. Next, we'll walk through how each of these pain points under the lens of a NetBrain deployment and tell you how it can transform the incident response lifecycle using automation. Following up with a more detailed look at the cycle in a NetBrain ServiceNow integrated environment. Then we'll go about demoing a live incident in the network and how NetBrain automation is used during each step of incident response. We'll show you how it looks when NetBrain responds to a ServiceNow ticket, how it can be used to resolve and remediate the issue, and finally, how we can proactively apply lessons from this incident into the next response. Here's an example of a typical incident response flow. This workflow is composed of 4 different phases: detect, identify, fix, and proactive. The first phase is the event itself, when the fault is detected by monitoring or some other kind of event management system. The next phase, identify, typically takes up the most amount of time. There's idle time immediately after ticket generation and before a first response engineer gets involved, as engineers are often busy resolving other issues on the network. Once they arrive on the scene, the engineer might not have a lot of details inside the ticket to go off of. In many cases, they end up investigating a lot of areas of the network to determine which one is causing problems, going device by device and CLI by CLI until they find something that's out of order. And if they discover a problem that's beyond their expertise, more engineers have to get involved during escalation and handoff, which restarts the idle time before more incident response. And if the ticket isn't properly documented, there will still be questions about what happened and where. Once the issue has been properly identified, it's time to design and implement a change on the network. And this means going through approval processes, checking potentially impacted areas, and finally resolving the issue. And the technical resources involved should strive to take lessons that were learned here and apply it towards better incident management processes, recording what kinds of issues appeared on the network, how they were solved, and making that know-how available to the next engineer that needs to resolve a similar incident. In every phase of this typical response cycle, engineers are going to encounter several issues. First, there's a lot of lost time in the process, particularly during the incident investigation. It takes time for an engineer to respond to a ticket. It takes time for engineers to find the problem area, and it takes time for the ticket to be handed off. Lost time accumulates over the life cycle of an incident, resulting in drawn-out repair times, downed processes, and lost business productivity. Even if a problem area is identified quickly, engineers are still going to rely on the CLI to perform most of their diagnostic work. CLI remains to this day a very reliable method of performing diagnostics across a network, but for large networks with potentially thousands of nodes and dozens of applications, the CLI balloons the amount of time it's spent investigating the issue. Finally, a lot of incident response is going to rely on the advanced know-how of your network heroes and subject matter experts. When you're dealing with multi-vendor and multi-technology environments, such as SDN, virtualization, and cloud, no one person is going to be able to resolve everything. Your engineers will have to escalate to someone who's more familiar with the issue, often losing visibility on the incident once they do. Once the network hero or the SME resolves the ticket, their know-how isn't easily parted to the rest of the team. The next time a similar issue appears, they might be called on to do the same thing again and again until someone else can learn it, or if they leave. These issues are persistent parts of this process, and they don't go away by throwing more labor at a problem. They're managed by finding smarter ways of going through this process. And that's the question: how do we improve it? Before we continue, I've got a poll question for you related to what you've seen so far. And if you could give your thoughts about it, we'd greatly appreciate it. We're curious, what percentage of all tickets require manual intervention for troubleshooting? Great. So it looks like most of them. That's what the answer seems to be. Thanks, everybody, for participating. So NetBrain provides a framework for implementing automation at each stage of the incident response flow. When integrated with an ITSM like ServiceNow, the benefits become immediately apparent. We can enrich ServiceNow tickets by integrating NetBrain's dynamic maps inside of the ticket, providing all users a detailed look into the networking environment and eliminating the guesswork involved in identifying the problem area. Incidents can be immediately acted upon by defining standard operating procedures like basic CLI diagnostics and executing them autonomously when a problem occurs. And by providing users a shared point of reference, collaboration is immensely improved across the entire incident. First responders can clearly share their activities, and higher tier engineers can painlessly share their know-how. In the context of a typical incident workflow, integrating NetBrain and ServiceNow will make it look like this. Each phase of the incident response cycle becomes easier, with idle time eliminated after ticket creation, thanks to first response automation, and engineers having the tools to accomplish their investigative work faster, thanks to NetBrain enriching the ticket and providing the means to automate other phases of the incident response workflow. Improving this response proactively is also turned into a clear, repeatable process. Engineers simply save the results of one incident for future reference and apply relevant automation tasks used there to the next response. In the context of our live demo, here's what this process will look like. First response automation is going to create several maps, both a map of the business service's critical path and any known problems associated with that area of the network. These are added to the map automatically and provided to engineers before they're even aware of the incident. Next, we'll show you how this application facilitates collaboration by having users add additional maps they create during the troubleshooting process, as well as share changes that they push to any of the problem devices. The idea here is that collaboration can occur within individual teams, as well as during any problem escalation. And engineers are going to be able to apply their own advanced diagnosis and provide it as a shared point of reference for the rest of their team. Then, when it's time to remediate the issue, NetBrain enables engineers to cleanly design a change and, if necessary, link the map to a change ticket inside of ServiceNow. Once the issue has been remediated, the last thing we'll do is save a map of this incident as another known problem in an effort to enhance our automation library. So this will be associated with the configuration item in ServiceNow. Much like the first well-known map that we've seen, it'll be triggered in the future if another issue arises. So we'll start with the crime scene map, which is going to use NetBrain's A to B path calculator to map all of the devices that exist between the affected business service and the user or device that is specified inside of the ticket. This saves engineers a lot of time that otherwise spend calculating the critical path that they need to focus on. Then we'll show you how NetBrain's library of known problems springs into action once an incident is created. NetBrain will summon other incidents that have occurred on this area of the network, common problems that may or may not be relevant to the issue. Now I'm going to hand it over to Raj, who will walk us through a live example of this process. It's all yours, Raj.
So let's jump into the demonstration right away. Now for today's demonstration, we're going to look at the ServiceNow ticketing system as our ITSM. Let's take an example of a company where we had a choppy video conferencing problem, as a result of which an engineer has created a ticket in the ticketing system, that's ServiceNow, with the problem. Here we have the laptop IP, and the issue has been clearly mentioned in the description, that it's a video slowness. However, there's a couple more things that they've specified here. That's the business service that you're using. It could be any of your voice platform or your teleconferencing platform. And one of our core devices, because most of my path, my video and audio paths goes through this particular device. So it makes sense to have this device in. Now with this information, I can go ahead and submit this ticket, give ServiceNow a few seconds. And what's going to happen now is that ServiceNow sends an API call to NetBrain. And NetBrain it can actually create a map, a live map of the area of the incident, and also pulls up a well-known problem issue like Chris just mentioned. We can quickly take a look at this map, this ticket which was just created. And you can see that there were two maps that were generated as part of this ticket. The first one that we can notice here is the lightning bolt, which is our crime scene. Our crime scene is basically the traffic path from the laptop of the person who has created the ticket, the laptop, and the voice server. So it's a path between the two of these points. And this is not a regular trace route. This is a NetBrain traffic path in which we take in consideration the routing tables, NATing policies, ACLs, VRFs, routing protocols, all of that, and then we create this traffic path. Now, if you think about this, most of my work in the beginning has been done by NetBrain versus me just going out there and looking for maps in my folders and trying to figure out where this computer is connected. Now, as a help desk engineer who's looking at this ticket for the first time, this is good enough information for me to understand that at least the path is working, which means it could be a further advanced network problem, if there is any. Just to gather some more information, I can see a bunch of knowledge information here on the left-hand side. We call it the knowledge tree. And I can select the regular health check just to kind of see the red down status, the up down status over here on this map and see if something is out of place. Okay, we can see a couple of issues, but this could be a CPU memory spike. But apart from that, everything else looks good. So what I'm going to do now is just tag my network team and say the path looks good, health is okay, please troubleshoot further. I could write this note, post it, and raise attention. The next map that we have here is the known problem map, which means that some kind of a problem has been detected in the past and it's part of a library. And the problem here is of a faulty transceiver. Now, as a help desk guy, I might not be able to understand all of these points. However, what I can do next is just escalate this to my network team and have them take a look at this. With that, I'll give it back to Chris.
Hey, thanks, Raj, for that look into first response automation with NetBrain ServiceNow. Now, before we continue, we've got another polling question for you guys related to what you've seen so far. Based on what you just saw, how much time would it save you per event to automate network mapping and basic diagnostics like you've just seen here? Okay, it looks like most of you said about 30 to 60 minutes. And that's 30 to 60 minutes that you won't have to spend inside of a lot of CLIs. So next, we'll show you how engineers can use this platform to enhance their own diagnostic flow. As I mentioned earlier, NetBrain is a shared point of reference here, allowing help desk users and network engineers to execute diagnostics on the same map, like Raj was talking about. It's commonplace for engineers to duplicate work in order to verify that standard diagnostic procedures have been run. But if this ticket needs to be escalated, then all prior actions taken during troubleshooting will be made available to everyone with access to it. CLI data, automation tasks, telemetry, and other diagnostic data is now stored directly on this map, leaving no room for confusion on what's been done so far. Junior operators can learn more effectively, and senior engineers can painlessly share their expertise. And once the problem has been identified, designing a change within a NetBrain map is trivial, and making it available to the change approvers is just as simple as escalating a ticket to another engineer. So, with that being said, I'm going to pass this back over to Raj, who can show us this in action.
Now, I'm going to assume a role here of a network engineer, probably a junior or the first response network engineer from the network team since I was tagged into this ticket. Now, the first thing that I noticed in this ticket is a lot of the groundwork has been done for me already, which is good news, right? So the help desk team is not really counting on me to go out there and physically create maps and look for data. So that's a plus. And next, I'm going to look at my crime scene, my crime ticket. As you can see, it's not a major issue here with the health and everything of the network. However, what has happened with this trigger is NetBrain has not just created that map for you, but it has also done some level of troubleshooting, or I would say basic triaging for you with the help of a runbook. So we're going to dive into NetBrain. There's an open map in NetBrain option. It's a URL, which takes us directly to NetBrain, opens that map, and from there we can get into more information. Now, one more part to notice is that the help desk really did not have to have access to NetBrain. They were able to see all of this as part of an embedded map, which was available in the ServiceNow integration. Now, when I'm looking at this map, everything looks good. And what I would like to also see is what kind of an information was collected by NetBrain at the time of the incident. I see some basic information collected. On the left, you can see a runbook. Now, runbook is your traditional playbook, so your troubleshooting manuals. But this is everything is codified here in a digital process, right? So NetBrain is able to run each and every one of these steps. It doesn't have to be 4 steps; it can be 20 steps, depending on what your troubleshooting processes look like. The first step that I see is just collection of some basic commands. The second one here is, again, I'm just retrieving configuration files at the time of the incident, with the help of which I could do a quick comparison of a before and after to see exactly what changed, if at all there was a change going on. And the last one here is just a health check of the network that we've already seen. Now, I don't really, I qualify as a network engineer, might not be a specialized voice engineer or someone who really understands QoS policies that well. But on the bottom, you can see a recommended action. And it's asking me to create a quality of service or run a QoS application on top of this map. Now, the QoS application gives us some basic information about this map. In the legend, you can see that a couple of these devices do have QoS policies. And the red color here, which indicates there was a baseline alert. So when I zoom in enough, I can see there was a drop at this particular interface. Now, selecting that drop will give me an idea and a graphical representation of what the behavior was like. And this is a baseline alert within NetBrain. Now, as I said, I might not be equipped with good enough knowledge to really go ahead and troubleshoot this further, but at least what I can do is I can collect enough information before I escalate this problem. The next recommended action was the QoS compliance check, which again, I can add this to the runbook and execute this command real easy. So what's happening right now is NetBrain is logging into these devices real time. There's a show how policy map interface collects information, but at the same time, it actually shows us if there's a device which is not compliant with the QoS policies of the company. In a few seconds, we should be able to see the result. And for someone like me who doesn't really understand policies that well, it's a good indication. So where does the runbook come from? So runbooks are created by someone in the company who really knows, their troubleshooting, right? So these would be the network heroes, the senior authorities who really know how to troubleshoot tickets well. And what they can do is, in order to save time in troubleshooting, they can codify all of their knowledge and then have NetBrain run that at the time of the incident. So look at that. It says that the committed rate, the required rate was, so-and-so, and then it was 512 KBs, right? The committed rate. And you can see that is the reason that there were drops. Right? Now, as an engineer, now I totally understand what the problem was. And what I would like to do at this point of time is I would like to copy this. First of all, I'm going to save this map for further, further use. And I'm going to copy this link back into my ServiceNow ticket. We could actually create the ticket here, and I'm going to save this for further use. With that, I'll pass it back to Chris.
Thanks, Raj, for that look at what this troubleshooting looks like inside of NetBrain. Before we continue, we have another polling question for you. If you just take a moment to answer it, this is about your primary collaboration tool during incident response. Okay, the results are coming in. It looks like most people are switching over to Slack and Teams these days. All right, thanks, everybody. So on to the final section of this process, right? Applying lessons learned here proactively. Based on what Raj has done during the troubleshooting process, we now have a lot of automation tasks and maps on hand after this incident. And what we'll do is save the steps that led up to this root cause and add another known problem back inside of NetBrain. The idea is we go through this process continuously, identifying all of our common issues and being able to either immediately identify or rule them out, just reducing the amount of time that it takes to actually resolve these issues. And to give you a quick example of that, I'm going to pass this back off to Raj.
Thanks, Chris. Let's dive back in. Now that I've created a ticket for my QoS engineers to take a look at this particular map and make the necessary changes, there's a time gap between me submitting the request and the QoS team actually fixing the policy. Right now, if during this time, if a similar problem occurs, I don't want my engineers to go back again and repeat the whole cycle. So for that, as Chris mentioned, what I'm going to do at this point of time is flag this map as a known problem with the policy. And I'm going to add this to my policy library. It's pretty simple. I'm just going to go save this as a QoS policy issue map. I'm going to send it back to the library that I have with my well-known issues in NetBrain. There you go. And just to kind of give you a demonstration of that, what I'm going to do is, for the sake of demoing it, I'm going to copy this incident, create a fake ticket right here with the same parameters that we did earlier. And as you keep, if I can scroll down, you would see the NetBrain automation section is empty. our goal is to look at the known problems right away. So now when I submit the ticket and then go back to my incidents, we'll give it a few seconds. My ticket's right there on the top. So I'm gonna go click on my ticket once again, scroll down, and now you can see that there's a third map which is attached here, and it says the QoS policy issue. So if the problem happens once again, and the cycle has to repeat, the help desk engineer can right away notice that, hey, there was a QoS policy and the map was created at so-and-so time. So this could be a recent problem, which hasn't been fixed yet. So this is how we can save a lot of time, especially if you're using Teams and Messengers a lot, you're sending screenshots, Visio maps, and all of that. But now you don't really have to hop between many tools. You can just keep it within ServiceNow and NetBrain and then solve the issue as soon as possible. With that, I'll give it back to Chris.
Thanks again, Raj. Really appreciate it. So before we wrap this up, we do have one last polling question for you guys. And it's really just regarding your existing ServiceNow deployment and whether or not you've integrating monitoring tools into your ServiceNow instance. As you may know, ServiceNow has a lot of certified third-party applications on its store that you can integrate your monitoring solutions like SolarWinds, PRTG in order to have them turn alerts into tickets. Interesting. So it seems that the majority of us here have not done that. We absolutely recommend going into the ServiceNow store. In fact, in order to get started with integrating NetBrain into ServiceNow, we actually have a NetBrain app within the ServiceNow store. It enables users to trigger and access NetBrain maps from the ServiceNow UI, like you've seen, and it helps you close the gap between fault detection and incident investigation. Once you get the app, you would need to go into your Snow system, search for plugins, and then then you apply it directly to your instance. And setting up the NetBrain app has been streamlined into a plug-and-play, GUI-driven experience. It's a three-step process, and it can be done by either a ServiceNow or a NetBrain power user. You point your instance of NetBrain at ServiceNow, you set up an HTTPS connector with a NetBrain account, and then you create API stubs in NetBrain to receive calls from ServiceNow, applying automation templates on the other end that define what Snow variables NetBrain is going to use to create triggered maps. And then finally, you define trigger rules inside of ServiceNow as to when and where these automation tasks should be triggered. And all in all, the NetBrain app can be set up from scratch in approximately 10 minutes. And with that, thanks everyone for coming by. Everybody stay safe, wash your hands for 20 seconds, and have a great day.